In this video, we're going to briefly introduce you to Minitab, a statistical software, and show you how to use Minitab to create simple displays of numeric variables such as histograms or box plots, and also compute summary statistics such as means and standard deviations. So when you open up Minitab, this is what you'll typically see. This is Minitab 17, so if you have a different version, it might look slightly differently. But the worksheet at the bottom here is essentially an Excel type spreadsheet. And you can enter data into this worksheet directly, right? Or you can import data from an Excel spreadsheet, which is what we're going to do for this lab. So the data we're going to use is taken from a survey of Math 37 students in 2015. It's actually the same data set we used in the Lab 1 instructional video. And to import data into Minitab from the spreadsheet, simply highlight the columns you'd like to use. We're going to start with the variable risk score. Copy it to your clipboard, return to the worksheet, and paste the cells into a column. Notice that I was careful to select the top of the column here when I pasted, and that's because we want the variable names to be displayed in this first header row, and we want the observations to be displayed in the rows which are actually labeled from there on out. So the first thing we're going to do with this risk score is calculate some simple summary statistics. And this can be done under the Stat menu, Basic Statistics, Display Descriptive Statistics. So we select the variable we'd like to summarize. And down here under Statistics, you'll notice there's a number of different options of things you can have Minitab compute. We're going to start off with some of the ones which are familiar to you at this point: the mean, the standard deviation, first, third quartiles median, the min, the max. And right here, we're going to forget about this for now, but just look at the total number of observations. All right. So if you click OK twice, you'll see in this top window a display which gives you all the information we just asked Minitab to compute. All right. So we can see that the mean risk score for all individuals in the sample was about 30. All right. Now, you'll recall that the variable risk score is computed. It's a composite score that's computed from student responses to a series of 15 questions about risky behavior. And the higher the risk score is, the more risky the student is sort of predicted to be. The maximum value for a risk score is 60 and the lowest is 0. And so 30 is actually really right in the middle of those two values. Besides summary statistics, we can also compute or display numeric variables in graphical ways to look further at their distribution. And so, for example, to create a histogram of risk score, we use the option located under the graph menu for histogram. We'll start with a simple one. Click OK. Once again, make sure the variable you'd like to graph is highlighted here. There's a lot of other options for changing the look and view of histograms, which you can explore on your own. But when you click OK, notice Minitab will make some choices of bins. It will display observations of the midpoints of bins. It looked like here it shows bins of width 5 in this. Actually, sorry, 2.5 in this. And actually, if you click on a bin, it'll tell you which values are included in that bin and how many observations there were. And so looking at this, you can kind of see that the distribution is roughly symmetric, about 30. Now, one thing which you might want to do in the future, two things actually you might want to do in the future. One is if you want to change what is displayed on the x-axis or the title, you can just double click on those and you can enter new text or whatever you want, and it'll change the look of the graph. The second thing is there are often times when you want to override Minitab's default for how it shows its bins, and that can be done by right-clicking on the bars and selecting Edit Bars. Now under the Binning tab, you'll notice there's several options. You can use cut points instead of midpoints for the interval type. You can also change the number of intervals, or you can actually manually enter how you want to choose the endpoints of the intervals. So for example, if I actually decrease the number of intervals to say 7, right, then I receive a kind of a coarser grained plot. It sort of captures the same qualitative behavior in this case, which is a good sign. You sort of want to make sure that you're capturing the right qualitative behavior for a variable. And choosing the right bins is a tricky thing, and you really need to try a few values to see kind of which plot you think gives the best picture of what's going on. Now, going beyond univariate summaries for numeric statistics, there are often times where we also want to compare the distribution of a numeric variable across different groups, different subsets of the population of interest. So to do that, we actually need some subsets to compare. And what we're going to do is, kind of like we did in the first lab, we're going to compare risk scores across the different majors. So I'm going to highlight my major column, copy it to my clipboard, and then paste it in the second column of my Minitab spreadsheet. Notice that the column title actually has a T next to it, and that's because Minitab is storing this as a text, which is Minitab's way of saying categorical variable. So now that I have both risk score and major together, I can start to compare the mean risk scores for different majors, the standard deviations of risk scores for different majors, and even create comparative box plots for risk score across different majors. Now for the first goal, computing the summary statistics for different majors, we return to the basic stats display descriptive statistics menu. And the only thing we need to change is under this by variables option, we're going to select primary major now. So once we do that, we can see that Minitab now will spit out all the summary statistics we asked for before, mean, standard deviation, and so on, but it will split those up by the different major of the individuals. So for example, we can see that overall actually, humanities and engineering had the highest mean risk score, but all of the groups were fairly similar. Social science actually had the lowest mean risk score. Now to display this information graphically, we can use box plots, and that option can be accessed also under the graph menu, box plots. If you didn't care about splitting it up into groups, you could use a simple box plot, but we're going to do with groups. We're going to select risk score for the graph variable, primary major for the categorical. And when you click OK, notice we get this comparative box plot of risk score across the different majors. Okay. Right. So when we look at this graph, we can see that actually, all the majors are somewhat symmetric. Business has a few outliers on the upper end, which might be driving up the mean risk score for business majors a little bit more than other majors. But these sorts of box plots, as we've talked about in class, can be a good way of comparing numeric variables distributions across different subsets of the population. If you want to include these graphs in a Word document or a report of some kind, you can simply right-click on a graph, click Copy Graph or Send Graph to Microsoft Word, either one. If you copy graph, it will be saved in your clipboard for future use.